Good evening. We are going to have a tutorial for the first short answer question from the mock exam. So the question says that a roller coaster of mass 290 kilograms begins at rest at the top of a hill. It then descends down a frictionless track until it reaches the bottom with 313,000 joules of kinetic energy. So right away, we know a couple things. Number one, that mass of the cart is 290 kilograms. The second, that we start at rest, so V1, we'll say, is 0 meters per second. Then friction is not an issue, so we'll ignore that. And we know at the end of its journey down the hill, it has kinetic energy, so we'll say this is time 2, of 313,000 joules. So, part A of this question says, sketch a diagram that shows the before and after for this situation. So, we're on a hill, we go down a hill, that's all there is to it. So we have a cart that begins up the hill, it travels down, so we'll say this is our time 1, and then at some time 2, we're at the bottom of the hill. If we want to label this any further, we can say V1 is 0, and at the bottom, we don't necessarily know the velocity, but we do know the kinetic energy. So that's it for part A. Part B says, calculate the speed of the roller coaster car at the bottom of the hill. So, we don't know speed, but we do know that kinetic energy is related to the velocity. Through the equation, KE equals 1/2 mv squared. So, we know mass, we know kinetic energy, we can solve this for velocity. So, in order to do that, we'll rearrange this equation. So first I'll divide by 1/2, or multiply by 2, which is 2 times KE equals mv squared. Then I will divide both sides by mass, and I will have 2KE over mass equals v squared. Then I'll square root both sides. And we will end up with square root of 2KE divided by m equals velocity. So now we can just plug in our numbers. So I have velocity equals 2 times 313,000 divided by my mass of 290 kilograms. And this will get you your velocity. Second, make sure when you use your calculator, and I'm going to use not my calculator, but a simple calculator, that you actually go through this very carefully, especially when you're using square roots. So I have 2 times 313,000, which is 626,000, divided by 290, gives me approximately 2,160, and now I will square root that. So 2,158.62069. Make sure you close parentheses if you used any parentheses. And so I get a final velocity of 46.46 meters per second. That's the answer to part B. Part C says calculate the momentum of the roller coaster at the bottom of the hill. So momentum, I hopefully recall, comes from the equation P equals mv, mass times velocity. So I know mass, I know velocity, I can calculate momentum. P will then equal 290 kilograms times the velocity I just found, which is velocity 2, if I want to be specific, times 46.46 meters per second, and don't need to square it, so don't do that. Be careful with your formulas. And so now my equation is easy to put into a calculator. It's simply 290 times 46.46. So the momentum that I calculate is 13,473, and the units will be kilograms times meters per second. So, moving on to part D. It says determine the height of the hill. So in order to determine the height of the hill, I need to look at conservation of energy. Conservation of energy says that my gravitational potential energy, so I'm going to say E grav at time 1, plus my spring potential at time 1, plus my kinetic energy at time 1, has to be equal to all three of those at time 2. Now, I know based off of the information given that there are no springs, so I can go ahead and cross off all my spring energies. I know that at time 2 I'm at the bottom of the hill, so my height I can therefore set to be 0. So I can cross that off. Then at the very top of the hill I know that I began at rest, which means since my velocity is 0 at the top, I have no kinetic energy at the top. So this then simply becomes gravitational potential energy is equal to kinetic energy. So that would be mg times h1, which is the height at time 1, equals 1/2 mv2 squared. So I can see just by writing this that mass will cancel out because it's on both sides. And I end up with g times h1 equals 1/2 v2 squared. So again, I'm looking for h1, so I'm going to go ahead and solve this for height 1. So I end up with 1/2 v2 squared over g. Apologies if that's hard to read. So I can just substitute values in now and find height. So I have 1/2 times my 46.46 meters per second squared over my value for g, which is gravitational acceleration, which is 9.8 meters per second squared. So my height 1 will be 46.46 squared times 0.5 divided by 9.8 will be 110 meters. So that is the answer to part D. Now, part E asks about a spring, which I didn't know about until this part. That's why I canceled out spring energy before. So I'm going to move this just so we can see. But on part E, I now have a little bit of a different conservation of energy. So I have a spring now, and I can do this conservation of energy from any point. I know that the kinetic energy at the bottom is 313,000 joules, so I'm just going to compare the energy at time 2 with the energy at now a time 3, which is part E. So gravitational potential energy at 2 plus spring potential energy at 2 plus kinetic energy at 2 equals the gravitational potential at 3 plus the spring potential at 3 plus the kinetic at 3. So some of these are going to be 0. I know that the gravitational potential energy for both is 0 because I'm at the bottom of the ramp, so I'm not going any lower. I also know that initially there's no compression of the spring. So at time 2 there is no spring pressing. And at the end I know that I'm stopping. So my kinetic energy is 0 as well. So subbing in my equations, I have 1/2 mv2 squared will be equal to my spring potential energy, which is 1/2 kx squared. And if I want, I could say k or x3. So I can see just by writing this, the 1/2 cancels. And since I'm solving this for the maximum displacement, I'm going to solve this for x3. So in order to do that, I'll divide both sides by k. So I get mv2 squared over k equals x3 squared. And then I'll square root both sides and end up with my displacement being the square root of mv squared over k. So now I can just substitute in all my values. My mass, 290 kilograms. My velocity 2 is going to be, again, 46.46 meters per second squared. And my K, which is given to be 5,000 newtons per meter. So, plugging all of this in, the maximum displacement ends up being I just made a mistake. Let me try that again. Divided by 5,000 is about 125, and the square root of 125 is about 11.2. So please rewatch this tutorial if you have any questions for short answer number 1.